Week 1, June 23rd to June 28th, new KNEW 2 substitution guided video tutorial. So with this section, this is a review. This will jump right into one of the topics in the new NEW portion of this week. In substitution applications, but this is a really important piece, and just really quick, I mean, I talk about it a little bit later on too. The biggest thing you will see in real life on when you use this is in the kitchen with recipes. So there are plenty of times you've probably done this without even thinking. You have to substitute things all the time, whether it's applesauce for oil, whether it's chicken for steak, whether it's milk for heavy cream. There are millions, I mean, I think I said hundreds, but there's probably millions of substitutes you can make between herbs and spices and meats and vegetables and whatever you want in your recipe to switch things up. In math, it might not be as exciting or as tasty, but basically you are doing the exact same thing. So you are taking one thing out, you are putting something equal or similar in for it, and you are allowing it to act as an equal. So looking at this, it's really important to recognize that not only you can do it, but you can do it without permission. So what I mean by that is you're not always going to have somebody tell you when to do this. You can do it anytime you see that equal sign. So anytime you see that x equals 4, when you see an x in the problem, you can place that 4 in there. And I think that's the biggest thing, getting comfortable with it. In the kitchen, you don't ask for permission to do it. So in math, you don't have to either. So looking at this worksheet, the first thing to notice is that the directions will say evaluate, because if you look at the actual problem, which is here, there is no equal sign in the expression. So negative 3x plus 5 has no equal sign. It's not an equation. The only equal sign comes in the substitution piece to it. So what they want you to substitute, they're telling you that x is equal to 4. Okay? So here is your x. They want you basically to take that out and to put in the 4. Okay, take the x out, put the 4 in. So the way I do this is I make a template for myself. What I mean by that is this. You'll see me do this all semester long. I'm going to rewrite this expression with everything except the variable in it. So I have negative 3 parentheses plus 5. What I do then is I've taken the x out, and now what I put in is the substitute, which is 4. Now I'm going to do my order of operations, which says I have to multiply before I add. I do negative 12, which is negative 3 times 4, plus 5. And I work down. I always work down. And that's negative 7. I circle my answer, and I'm done. So let's look at number 2. I see that I'm substituting 1/2 for x. Okay, and I've highlighted the x, and I see where I'm putting it. I'm going to write my template, so I'm just rewriting my expression with everything except my variable in it. And now I'm going to place my 1/2 inside of my template. So I have 6 times 1/2 plus 10. Order of operations says that I need to do my multiplication first. So 1/2 of 6 is 3 plus 10. That gives me 13. For number 3, when I'm highlighting anytime I see an x, I actually see it in 2 places. I see it x squared and I also see it times the 3. So when I'm plugging that -2 in, I actually have to plug it in to 2 different places. When I create my template then, I put those parentheses anywhere that I see the x. So I need 2 sets of them as well. The parentheses become important because they not only act as a placeholder, but when you're plugging it into your calculator, you are smarter than your calculator, and they need to be there because if you put in a negative and square it without the parentheses, your calculator will actually give you the wrong answer. So I'm going to plug in the -2 everywhere where I see those parentheses because they were all x's in this problem. And then I'm going to evaluate. So -2 times -2 gives me +4. And then this -3 times -2, I can look at this as two ways. This piece, I can look at it as a -3 times a -2, or I can look at it as -3 times -2. I like to look at it as -3 times -2. So -3 times -2 is +6. 4 plus 6 is 10. If you look at it the other way, you would get negative, and then 3 times -2 is -6. The double negatives become a plus. It will come out the same either way. I just don't like to deal with the double negatives and turning it into a plus. All right, for this one, we have 2 different variables in it. So when I highlight, I'm just going to be careful. I'm going to do x with blue and y with green. All right, so I'm plugging a 2 in for x, and I'm plugging a 5 in for y. So I have 2 to the 3rd power minus 7 times 5 plus 3. 2 to the 3rd is like saying 2 times 2 times 2, which is like saying 8, minus 7 times 5, which is 35, plus 3. It's very important when you have all subtraction and addition. Order of operation says, please excuse my dear Aunt Sally, but there's a flaw in that. Addition and subtraction needs to be done from left to right. Okay, just like you're reading a book. So 8 minus 35 is -27 plus 3, and then -27 plus 3 is -24. If you plug it in your calculator all at once, just like that, just as you see it, it will do it correctly. Don't do any funny business with negatives, positives, the whole thing. 8 minus 35 plus 3 will give you -24. All right, the last one's a doozy. We have this long thing, a to the 3rd plus 2abc minus 3c squared. We have a equals 5, b equals 9, c equals -1. So we have a in a couple places, b in that one place, and c in a couple places as well. I'm going to write out my template with all these parentheses, and I'm just going to color code it so that I know where I'm plugging things in. Now again, this is open to human error, so this is all fine and dandy until you mess up your color coding system, right? And then all bets are off. I hope you can see the yellow. If you can't, I apologize. So we can do each piece separately, and then we can do the parts at the end. So 5 times 5 times 5 is 125, which is 5 to the third power. This piece, okay, 2 times 5 times 9 times -1. It's definitely going to be a negative because I have that negative in there. 5 times 9 is 45, times 2 is 90, times the 1 is just 90 still, and it's, again, negative. Now, over here, we have to do the exponent before multiplication. That's very important. Always, 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 always. Okay, so we do -1 times -1. That's the -1 squared, which equals +1. And then we're doing +1 times -3, and that equals -3. So it's going to be 125 minus 90 minus 3. And again, we're working left to right. If you're putting it in your calculator, that's okay. Put it in just like you see it. So 125 minus 90 gives you 35 minus 3, which is 32. And I'm all done. So go ahead, try some more. Try some more on the independent ones. Let me know if you need any help, and I will talk to you all soon. On the independent ones,